I do think that we're going into this era soon also where kind of apps will almost be like Polkadot's original vision of like having on-demand rollups with parachains and para threads. I think that's something really cool that we could move into in the modular space right now. That's very much underexplored at the moment.
Nothing said on 0x Research is a recommendation to buy or sell securities or tokens. This podcast is for informational purposes only, and any views expressed by anyone on the show are solely our opinions, not financial advice. Boccaccio, Ryan, and our guests may hold positions in the companies, funds, or projects discussed. What's up, guys? Welcome back to another episode of 0x Research. As a disclaimer, today's episode is sponsored by Union. I'm joined by Karel, the founder and a core contributor at Union. Thanks for coming on, Karel.
Yeah, thanks so much for having me.
Before we get started, do you mind running over what Union is and what you guys are building?
Yeah, of course. So Union is an interoperability and settlement layer. So for kind of the regular user, what this means is, again, a project that connects different blockchains. What we focused on is being really fast in doing this. So messages and transfers get sent really quickly between blockchains, but as well as being extremely secure and decentralized. So we don't rely on like oracles or some service that we are running that could potentially be hacked by any group. And that's especially important if you're doing bridging.
That makes sense. And what's the motivation behind it? What, apart from not being reliant on other protocols, what are the problems you guys are trying to solve?
Yeah, so obviously everyone's kind of building like app chains, app specific rollups. They're following in Hyperliquid's footsteps of if you have like your own environment, you can build a really cool product. So this idea that like the L2 centric roadmap of Ethereum is kind of what everyone is doing in crypto is very real. With that, you get a majorly complex like architecture for how these blockchains need to interact and communicate with each other. Extremely annoying for users, like you don't really want to do bridging, but also actually really annoying for developers because you don't want to like rebuild an entire ecosystem. You want to rely on like already products that are on someone else's blockchain. But if you actually look at like the current landscape, there's not really like I would say like bridging APIs that would work if your contract does like 1,000 bridge calls every minute to interact with the DEX on another chain. There's like no infrastructure really that handles that. All of the infrastructure that we have right now is, to be honest, kind of like most bridge protocols do like 1,000 bridge operations per day at most on a really busy day, right? It's like it's almost like the post that's being sent. So that was what we were trying to like solve, have like that first pipeline that is indeed kind of suitable for high traffic interoperability. The other thing, and that's more like really philosophical, that I was seeing personally is we spent so much time like in the early days of crypto designing blockchains that were like secure, thinking of like Byzantine fault tolerance and such. But if you look at a lot of intro protocols, they're like multi-sig to relay or kind of setup. And if we build like the wider blockchain landscape around this idea that everything is connected by just a bunch of multi-sigs, then we lose that portion of decentralization and security, right? Like we've got a bunch of middlemen that are basically just running a single server in the US, subject to all regulations and such. So we wanted something that even if I personally, as like the founder of Union, decide to pull the plug, like the network itself could not be pulled by me. So it was our second biggest objective to achieve.
Perfect. That makes sense. And how does it achieve or aim to achieve these objectives? What does the backend architecture look like?
So basically, in designing this, the first thing, like if you're not going to use like a multisig or Oracle or something, means that you need a different like security mechanism to verify that a transfer occurred. In our case, we use light clients for that. Light clients are kind of like the best that you can do at the moment. Basically, what it means is like we generate these certain mathematical proofs about like validator sets or the consensus algorithms of the different chains that we connect to. So in the case of Ethereum, that is tracking the sync committee. In the case of Bitcoin, that's basically verifying the POW that's occurring, and allowing anyone to like provide those proofs. So it's not just that the Union team runs like a relayer and a prover. No, like we have this network of solvers that basically monitor different chains that have like transfers going in and out of them, and they will see, hey, there's this batch of transfers that could go to this other chain. Let me generate a proof right now and settle these transfers. Because with light clients, our smart contracts kind of guarantee that you cannot like create fraudulent proofs. Anyone can like boot up a relayer or a solver right now and start serving traffic. And that is what keeps it so decentralized. Because basically, if there's like traffic going on, anyone can make money with it. And as long as you can make money with it, someone on earth will be willing to like boot up a relayer and either compete against existing ones or keep serving the network. So there's no like reliance necessarily on us having like a server somewhere securely like facilitating all the transfers right now. And actually, like if Union Labs at some point disappears, as long as people are using Union, there's always the room for a relayer to be operating. On top of that, we have our L1. Our L1 acts as this proof aggregation layer for all of the work that occurs. So that is what relayers connect to and use to orchestrate. And over that, we generate one big ZKP. That has another like quite nice advantage to it, because we don't only like aggregate multiple transfers in one single ZKP, we aggregate multiple chains in each ZKP. And that gives us a really nice gas profile compared to, for example, XLR or Layer 0, where they don't aggregate over multiple chains. And so what you see is it doesn't matter for Union if you have, let's say, 10 transfers going from Ethereum to Solana, or one transfer from Berachain to Solana, one from Ethereum to Solana, one from Osmosis to Solana. Like the aggregation behavior is exactly the same and the verification cost stays the same. And that at scale allows you to get like really low gas prices. So if you have about 20 transfers occurring at the same time, Union becomes about as cheap as a cross, like slightly more expensive, but I think it's only like 5K gas more expensive. And that's actually quite amazing with all of the cryptography happening under the hood, the zero knowledge proofs. Like at not even that many transfers, to be honest, it already becomes like one of the most gas efficient protocols out there. So that's a really cool behavior that actually is because we chose to be this decentralized and secure. I mean, it's coming from the fact that we chose ZK.
Yeah, that is cool. And talking about ZK, one thing you guys mentioned is that you have a ZK powered consensus verification. Can you run over what that exactly entails?
Yeah, so this ties into those light clients, right? And light clients already known to be like the most secure way to do bridging verification, but the downside is light clients usually are on chain a lot more expensive. For the more technical people, like a light client basically is a re-implementation of the consensus algorithm of a specific chain. So you might re-implement kind of Tendermint in Solidity, and you have the relayer provide like the next block. The smart contract runs through the logic and verifies, yeah, indeed, like this is still the correct block. Um, you can really imagine this gets really expensive, right? You're going to spend millions of gas on each light client update, and so the bridge transfers just become way too expensive. So the key solution here is actually generating a ZKP for your consensus update. Instead of doing it in the contract itself, you have a circuit that performs all this computation. Cool thing is now, like the cost stays constant. So if a network has 100 validators, 1,000 or 1,000,000, doesn't really matter because the ZKP has a constant cost associated with it. So you always know like a light client update is 220K gas, give or take. And the cool thing with ZKPs, of course, is you can aggregate them arbitrarily, right? Like you can combine multiple into new ones for those that are familiar with like the cryptography behind this. And so it has a really good scaling behavior once you can get into like serving thousands of blockchains, right? Like it still stays the same constant cost. I think out of all like interop providers right now, Union is the only one that has that behavior. That like as you start adding more chains, there's no additional cost to it.
Interesting. How does that batching or I guess aggregation mechanism work? More specifically, maybe.
Yeah, so I'm afraid like I'm not our lead cryptographer, so I can't go too deep into those details. But basically, what we do at the moment is we actually generate snarks, and snarks you can aggregate those arbitrarily and still verify them as a snark. The input size does increase, of course, if you were to do something like that. But in the end, like you still get major gas benefits. We have a couple of different modes actually in the architecture too. So one of our partners that we work with is Aligned Layer. What they do is CKP attestation. But depending on like the type of connection that you open through Union, you can choose to use a light layer as well. And then you aggregate them with the attestation service. You can use Nibra, and then instead it's actually properly like cryptographically aggregated. What we see here happening is that there's a latency trade-off occurring. So basically just generating the ZKP, settling it directly on chain, lowest latency. And so a solver will choose to do that if there's a lot of money to be made with that specific batch of transfers. If people have set like really low fees in their slider, they're cheaping out that day, then a solver basically will feel secure that no other solver will go with the fast path. And so we'll just submit the ZKP to be aggregated with Alliance or Nibra, wait 30 extra seconds, and save massively in gas. And it can do this for multiple ZKPs, right? It can decide like this one batch just doesn't have enough fees at all, but maybe 3 batches in total have enough fees collectively to be settled that way. So there's a really nice dynamic system. Like if Ethereum gas prices suddenly spike massively, then basically solvers will decide to increase transfer times by a minute or two to leverage aggregation mechanisms to still be able to settle these transfers.
That makes sense. And in terms of, have you guys run analysis on what you think solver fees will, or like what solvers will demand? Or do you think, often we hear that with Intense, for example, that it's going to be a race to the bottom. Do you think it's going to be a similar case?
Yeah, I think on the one hand, race to the bottom that is doable for solvers to still operate. So we specifically chose this design because, if I'm going to be honest, solvers are usually rich, sophisticated market makers. So I wasn't looking to give them a way to make insane amounts of money. I was looking for a way to create a system that would cost optimized for the user. So ideally commoditize for the solvers until they make just enough. That's basically the best price a user can ever get. And that ties into this vision of like we want to be in a world where tens of thousands of bridge operations are happening like every minute between thousands
Yeah,
of blockchains. And for that, you want it to be like really cheap in the end instead of extremely expensive. So have a system that can do high volume and make money off that instead of high value transactions, but only a few.
that makes sense. And I guess, how does the Comet BLS work? How is it different to the Comet BFT, and why is it different?
Yeah. So for kind of our aggregation chain, we decided to redo a big portion of Comet BFT. And it had to do with that we include the consensus of this relay chain into the final ZKP as well. So we made a few design choices to make it much more ZK friendly overall. One is using BLS signatures, really good for like reduced state growth over time, really good for verification. As well as we figured out some cool tricks with like Ethereum precompiles that actually made like verifying our ZKPs even cheaper by going down that approach. Other things we implement is we use MIMC hashing instead of regular SHA-256. We actually have like a slightly adjusted storage trie format. And the cool thing with this is like this all made like the prover even faster overall. So in the end, I think right now, like consumer hardware, can kind of generate a proof in about 30 seconds, maybe 20 by now. And our biggest thing that we're working on right now is GPU acceleration for this. That'll be the biggest win I think that we can get out of this tech at the moment. And so that, to be honest, puts like the theoretical latency for Union at around, well, right now, 20 seconds on consumer hardware. And with GPU acceleration, probably 2 to 4 seconds, which means that we're mainly waiting on other chains and not on ourselves, which is technically the best you can do as a interop provider, is if you're like faster than the chains that you connect. And that's what we, to be honest, kind of see right now on testnet. We did I think the fastest transfer we facilitated was between Stride and Berachain, and that took about 23, 24 seconds in total.
With regard to that, if a chain has faster block times, or if a chain is just faster overall, does that also lower your latency?
Yeah, with that, it does need to have like faster finality. That's what matters for us. But what you see right now is that is kind of the case. Like Hyperliquid and such, they all finalize really quickly too. So with these like single slot fast finality chains with like sub 1 second block times, that's actually what I think is the future for like all blockchains out there, because that just provides everyone the best UX, including us. Like we love that on the back end with engineering team.
That makes sense. And I guess lastly, on the architecture side, how does Galois work? What is it? What does it exactly do?
Yeah, so our original like cryptographic stack, we implemented that ourselves about 2 years ago, like the V0, using NARC. So that's still the kind of, I won't say legacy ZK stacks, because you actually build the most performant ZK stacks with this. But these days, everyone is kind of using SP1, RISC-0, maybe BNES and such. But when you handwrite the circuits, at the moment you still get the highest performance, and that's what we did specifically because we didn't need to do like a very general compute. We knew exactly what our problem space was. Um, NARC at the moment is still what we're running and allows us to also endeavor into GPU acceleration. And all of that we folded into Galois, which is the prover that we use that's compatible with Firma, with Sindri, that different prover backends can at the moment serve for us. Long term, I'm not sure if we're going to stick with that. We have a few experimental projects right now to actually switch away to a new prover backend. The main reason for that actually is that there's just this obviously Cambrian explosion of new blockchains out there with different consensus mechanisms out there. And so we were moving at the moment to make it easier for other ecosystems to make themselves union compatible. Instead of us writing the circuits, writing the cryptographic backends to do these line proofs, make it easy for third-party developers to actually write this, deploy the code, and start generating proofs. And for that, you, to be honest, want to have them be able to use vanilla Rust, no circuits, but basically just do the same code that they write in their smart contracts or their regular backends. So for that, we're looking at potentially using a zkVM.
That makes sense. Um, in terms of integrating other chains, you said you want them to start handling that, but what does the process look like on your end right now? And I guess more specifically, let's say like Berachain or a Bitcoin L2, what would it look like for these versus Solana Hyperliquid?
Yeah. So at the moment, all are relatively similar. Basically, the big thing to do is that light client, the code that generates the ZKP. That's the hardest portion at the moment for new developers coming in to code out, and that requires the most, I would say, fundamental blockchain knowledge as well, right? That requires understanding the underlying consensus, what does this chain specifically do. Funny enough, we always joke about this, everything turns out to kind of be a re-implementation of Tendermint with a couple of changes to it, especially Hyperliquid, for example. But Solana is actually the big outlier here. That is very different from all other blockchains because it chooses to, for example, not Merkleize state at all, which for us actually makes it a bit more challenging because now you cannot easily generate storage proofs anymore, which is what in the end at the core we do. We generate storage proofs to secure these different asset transfers. For let's say if you're building a new Bitcoin L2 using the Cosmos SDK, at the moment we actually just have contract stacks that you can immediately deploy. So for 99% of developers out there, it's actually go through the tutorial, use our deployer CLI, and you're good to go because we have so many pre-configurations at the moment that all just kind of works out of the box.
Interesting. I guess what are some of the trade-offs that come with Union as opposed to other interoperability protocols?
Yeah. So one thing that's really cool, I think, at the moment is how we beat other general message passing bridges right now. Is Union is not based on a hard coded set of confirmations, which XLR and Layer Zero are. So XLR for a specific chain might wait for 30 confirmations, but if a chain finalizes, let's say every 15 blocks, that means that on average, XLR overshoots by 15 blocks, waiting for too many confirmations than is theoretically possible. Theoretical necessary. Union always hits that exact theoretical one where it's safe to do the bridge operation, always mathematically. That's really cool. The downside is intent-based bridges are technically faster because intent-based bridges can YOLO and say we don't even wait for the one where you theoretically need to wait for it to be secure. We just take the reorg risk. And Union at the moment, we choose not to take that reorg risk because obviously we're all smart contract based and you can't handle such a risk in the system. You want to maintain one-on-one backing. Which means that for chains where you need to wait quite a long time for finality, you are faster off with an intent-based bridge. Downside with an intent-based bridge, of course, is not all assets are supported. You cannot do general message passing, etc. So Union in that case does support them really well. Other downsides, I would say at the moment, but I think that's kind of an upside, is indeed that because Union is so decentralized, you cannot really shut Union down. We do have contracts to do circuit breaking, rate limiting for specific assets, but that's more up to the asset issuers themselves to decide what is the bridging behavior that I want. By default, Union will just allow any traffic to always keep on going, and we don't blacklist or whitelist specific users.
Interesting. That is good. I think that's also a positive as opposed to a negative to not be able to blacklist and just have um, circuit breaks, etc., just to slow stuff down if needed.
Yeah, I think it's
Um,
better if the base layer is like open for anyone to use, and then you just leave like developers building on top of you to add their own custom behavior.
yeah. How do you see in, intents and general messaging protocols play over the next few years, or over the next? Because, like you said, I personally use intents because if I'm bridging, I just bridge big asset to big asset, and it's much faster. But I know there are risks involved. How do you see that changing?
Um, Yeah, so I like the final like solution, to be honest, is like intents at some point go away and everything is ZK based, light client based, and we can just mint any assets because that means that solvers need to no longer manage inventory anywhere. If we're in this world where like every chain is like sub 1 second finality, right? They're all insanely fast. Then there's really like no reason to operate over intents anymore. Um, Cheaper for users, to be honest, easier for developers to reason about too, because right now with intents in your smart contract code you kind of have to handle like, can this actually be sent over, right? Like, what's the asset ID that I'm dealing with? You need to like store supported asset lists, and they always turn out to be basically USDC and maybe two or three more, but that's kind of it that we can do intent based. So the final solution really is like something that's based on proofs. And the cool thing there is like you can have different bridge providers still all use the same proving mechanism, basically have it all be block hash based, and that way you can basically aggregate the block hashes they provide. If they're like in unison about like what's the hash of the origin chain, then you can allow all of them to mint freely. So that kind of makes bridge providers more like security providers in the end and aggregation layers, and not really asset custodians anymore. That would be like the best final solution for crypto, and that's kind of what we're working towards. But that solution like is still like at least 2 years away, I think.
Fair, makes sense. One more thing. This is kind of related to the earlier section, but you mentioned that Solana makes it difficult because they don't really have state hashes. Versus that's what you Merkle hash. They don't Merkleize it. Versus that's what you guys really need. Can you um I guess like my line of reasoning is on Ethereum, you can just take that and you know that it's correct. That's the good state. But on Solana, how do you access the good state or the verified state?
Yeah, exactly. So for those listening, basically the way Ethereum and a lot of blockchains work is if you have like the block header with the block hash and you know that that one is correct, you can create what we call storage proofs, which are these really tiny proofs to show that this smart contract has these values in it, or that this transaction previously was successful. And that's really useful, for example, to prove that there's 1K USD in this pool or in this vault. And that's kind of how bridge providers work. Because what you do is you do a proof that someone deposited 1K in a vault. And that means that now you can like subtract 1K from another vault on another chain. Now, because Solana doesn't Merkleize state, you cannot generate these tiny proofs that these events have occurred. What it forces you to do actually is to Merkleize state in the Solana smart contract itself. So you don't rely on the node doing this work for you. You actually perform this in the contract. There you can be clever with it too. So you can use RSA accumulators, which are like a different cryptographic principle that kind of allows you to do the same, generate like inclusion proofs as well. And so, like, actually, all of the logic that normally was handled by the blockchain itself, you're now doing inside the smart contract. And so, that again, like if you're implementing this from scratch, it requires you to just understand a little bit better what the tools are available to you. Luckily for us, like Solana is obviously like really fast, and they're like if your transaction can be paralyzed and doesn't like touch any state that's contended with, then it's extremely cheap. If you were doing Merkleization in contract on Ethereum, you'd be paying quite a lot. But on Solana, in practice, you actually don't pay that much for it.
Interesting. I assume it's still heavy on the computation side, or no?
Well, heavy, like it turns out to still be just a few cents, so really not that much, but definitely on the heavier side. It's, I think, something that misses, but the thing is, it's part of Solana's philosophy, right? Like it's also hard to set up a node and just keep up with the actual validators. But light clients normally actually make this much easier for others to keep up because you have to like process less data to know your data is still valid. So I am hoping that Solana at some point adds these things on top of the roadmap. No, right now with their partnership with Succinct and such, so they're a bit more open to actually making like the base layer more provable.
Interesting. Um, what can uniquely be built on Union that can't be built on other general messaging protocols?
Yeah. So one thing that I think is extremely cool at the moment, and this ties a bit into like how we saw how cool intents are and what they enable you right now. If you build a protocol on top of Union, you basically use like our packets API, which is very much similar to like using TCP, like packet comes in and such. But you can actually opt in to have your packets be intentfully delivered as well, by basically adding like one extra entry point to your smart contract. And solvers will kind of automatically figure out these specific like data packets. I can use the intents route to fill them, provide assets myself. And for these, I need to actually generate a proof. But you as a developer, like, don't need to implement two different protocols. You're not actually implementing like intents on top of a message passing bridge. You're not importing like two different API standards. You're basically for certain entry points, for example, swaps or providing LP, saying this can be provided by someone else, and then using our acknowledge mechanism to repay the solver. So we saw someone, for example, implement a cross-chain DEX in kind of like 150 lines of code because they realized like, hey, because you have this like solver kind of transparently built into the system, you get access to whatever asset you want. And I think that's kind of like outside almost the ZK portion that we do and the cryptography that we do. Just a really cool effect of how we designed like the core protocol itself to be like to have all of the lessons from like layer 0 v2 from across from xlar and combine all of them in just a really cool api to work with. And what we see people build right now with that, so we have the Fluton team who's combining that with FHE to do private intents. What I think is really cool about that is obviously, like if you do everything intentful, you always get the worst price, right? The solver's always going to front run you and sandwich you, etc. So the whole objective is like, all right, can we like indeed like build an L2 using FHE and try to keep this like private for as long as possible, make it harder for solvers to actually front run the end user. So that's a really cool one. Another team right now, SettleX, they're building a confidential clearing layer together with Archium. So that basically has this property right now, like solvers are rebalancing across various networks, exchanges as well, right? Like exchanges like Binance need to make sure that they have assets on every single chain available for people to withdraw. But anyone can monitor this at the moment. They can see that these positions are being placed. And so that leaks like a certain strategic info, right? So like you know where outflows are going ahead of time. And if you think about it, like in TradFi, clearing and rebalancing is always private. Like you don't let your competitors know what the positions are that you're taking. So by combining like Union and confidential compute, you can build a layer that basically does all of this rebalancing completely privately.
The intent comment about people front running you, that's another trade off for them. I think I noticed it recently is that it's anything you put on the chain, if there's a, like you said, these are sophisticated market makers, it makes sense that they would want to front run you. How do you, we already kind of touched up on this, but how do you see modularity change over the next few years?
Yes, I think we're going to see more high performance modular chains that do quite a lot of functionality. So maybe rely on DA still for Celestial and on the chain, but I think still like have a lot of the stack actually in their own node because that just allows you to build like a really high performance environment at the moment. Um, I do think that we're going into this era soon also where kind of apps will almost be like Polkadot's original vision of like having on-demand rollups with parachains and para threads. I think that's something really cool that we could move into in the modular space right now. That's very much underexplored at the moment, and that's something that rollup as a service providers and I mean intro providers really need to jump in on. If indeed like the experience for deploying your app is as simple as Supabase, right, where in like 20 seconds you have like a Postgres instant, your dashboard, and you can start building some cool stuff. That's really the same with setting up your own like high performance L2. For that, like all of the peripherals need to come into place really nicely. Right now, like you do have some bridge support, right? Like you could get, I think, like Relay included or Hyperlane, but there you still have the issue that you're connected to like one or two networks when you set this up. especially like within all of these different rollups that people spawn. You still see like very limited connectivity. So I think that's like the big thing that needs to be solved before we actually see these like swarm of microservice blockchains succeed. And I think until then, it's still going to be a little bit monolithic.
That makes sense. And what would you say are the key issues, not in just modularity, but also interoperability? Like, what is something that you think you need to fix over the next 1 year?
Yeah, I think Interop, to be honest, it's both fees and speed. We all love seeing tweets from certain Interop protocols saying like how cheap this one route was, but to be honest, if you look at many routes, you're still paying like $90 to do a medium-sized transfer. Sure, like the fastest they did that day was 50 seconds, but in reality, usually you're still waiting 5 to 6 minutes. Uh, I think right now some people might say like, yeah, but do you need to? You don't do it that often, and that again is reminiscent of like uh, 30 years ago online shopping, where people say, yeah, but how often do you do online shopping? It's fine waiting 30 minutes for a bank transfer, right? And you're like, oh, turns out to actually just be like fundamentally limiting an entire market sector. And if indeed like you could do an online payment in 1 second, people do more, and shops become more successful. So I think that's very much the same with like blockchain and modular thesis and having multiple chains out there. People kind of wonder like, do we need a second one? Is the advantage big enough? But if interop is like extremely fast, extremely cheap, then as a user you don't get annoyed by it at all, and then it's super obvious to go your own route and build your own L2 for your app.
Yeah, that makes sense. And on top of that, what are some key things that you guys are focused? Like, what should we expect from Union this year?
Yeah, so basically expect mainnet this year. Testnet 9 is coming out extremely soon. That's our final testnet. It has all of our latest features in it, our new proving backend. That also means that we're close to the conclusion of our trusted setup ceremony. So we've been running one of the largest ceremonies right now to generate the verification keys for ZK circuit. So we've had like thousands of people participate now. The actual payload, I think, is about 600 gigabytes. I think with that, we've crowned it as the largest one at the moment. And so that's like actually the first bit that people can use to contribute is participating in that ceremony, getting in the queue, and contributing some RNG to ensure that our underlying algorithm is secure.
Perfect. That's exciting. And before we end it, do you want to tell our listeners where they should head to find out more about Union?
Yeah, just go to our website, union.build, and check out our Twitter, union_build. That's where I do most of my ideation and thinking. Obviously, join our Discord, participate. Next couple of weeks is kind of a new moment with our next testnet for users to become active, and as well for people to interact with the projects building on top of us, like Azure, Fluton, and SettleX, kind of the first era of truly modular multi-chain projects.
Fantastic. This was great, Karel. Thank you for coming on.
Thank you so much. Have a nice day.